Thank you for clicking on my video today. We're going to talk about the filament hack for the XYZprinting da Vinci 1.0a printer. By this, we're going to enable the use of third-party filament instead of the cartridges offered by XYZprinting. To start off, I'm assuming you're using a ready-to-run printer. So we're going to go ahead and unload the filament. Now when the filament has warmed up, the extruder is going to be reverse feeding the filament. So you're just going to have to push over the lever and pull out the filament. Then we're going to push it back into the cartridge and use the upper hole to keep it usable sometime later. So to show you, we're going to go into the info and cartridge stats to show you that it's currently remaining 149 meters out of 240. It is a black ABS filament that I'm using from XYZprinting. We're just going to go ahead and remove the box. The next step will be modding the EEPROM of the filament cartridge so we can use external filament and keep resetting the cartridge box. To do this, we're going to go to GitHub/Voltivo, which is a company that offers third-party filament, and they also offer the Da Vinci Filament Reset Arduino sketch. We're going to hit download zip. Then we're going to open up the zip file, and there you will find an .ini file, which you can open with the Arduino IDE. It's going to ask to move the .ini file to a new folder. We're going to hit yes. The code is pretty much ready to run. Looking through the code, you can find that the used pin for the data port is pin number 7. In my case, I'm using it with the basic Arduino Uno platform. And if you continue scrolling down, you will see all the functions that are required for the application to work. And you will also find a few settings that you can alter. These settings include the cartridge length. We're going to change this to 240 meters. So just uncomment the line and comment the line above. You can also change the extruder temperature. For my filament, I'm going to use the suggested 232 degrees. To do this, we're going to change the 230 degrees and we're just going to verify that it is E6 as it says. So we can alter this to the value required for 232 degrees, which would be E8. So we're just going to go ahead and alter this line. Comment the top line and uncomment the new line. You may also change the bed temperature if you prefer. We can increase this to, let's say, 92 degrees, which would be 5C. And we're just going to add a few declarations so you know what this line means. So our settings include 232 degrees extruder temperature, 90 degrees bed temperature, and 240 meters of filament length. I assume you know how to set up your Arduino. We're just going to go ahead and upload the sketch. As you can see, the Arduino is being flashed right now. And now the flash is completed. The small EEPROM chip on the bottom of the cartridge has 3 pins. If you look at it from this way, the bottom left is ground, the middle one is data, and the top right is positive. I prepared a small wooden board with 3 pins sticking out. I labeled them ground, data, and positive. And we're going to use this to make sure we don't do a short and have a proper grip of the pins while programming the EEPROM. So now we're going to go ahead and plug in the wires of the small programming board. We're going to go ahead and plug in the ground wire on a ground pin on the power side of the Arduino. The data pin goes into the pin 7. And the positive pin goes into 5 volts power. Now we're ready to go. So before we're going to start flashing the EEPROM, we're going to have to open up the serial monitor. Now when you see this weird output, you are probably on the wrong baud rate, so make sure you pick 115,200, and then you will see testing connection to Da Vinci EEPROM chip. So now make sure when flashing the EEPROM you keep a firm contact to the pins, so to make sure that you always have a solid connection so we don't prick the chip. The flashing doesn't take longer than 1 or 2 seconds. And here's the flash results. To make sure the text doesn't run away, I'm going to disable auto scroll, and then we're just going to go ahead and unplug the USB on the Arduino. We're going to go over these results, so I'm just going to open up a small text editor, which is called Sublime. I'm going to go ahead and copy those lines into Sublime so I can show you what this all means. The top block is before resetting the EEPROM, and the bottom block is after resetting the EEPROM. The EEPROM values are quite easy to understand. On the first line, the AK in CAK means that we're using an ABS filament in the color black. K stands for black and A stands for ABS. So down here on the bottom, we have the last line of bytes contain the maximum factory filament length, and the fourth line contains the remaining amount of filament in the cartridge. So in the first block, it should show you the amount of filament that I've had before resetting, and in the second block on the same position you will see the new maximum length. I'm gonna go ahead and mark the bytes that are responsible for the current remaining filament length. I'm going to paste this into my calculator and do a byte swap and then convert it to decimal. And this is going to show me that we've had 149,000 millimeters. So the old remaining filament length is copied as a hex code, which are the blocks 94, 46, 02 and 00. Which you have to do a little endian conversion, so the byte swap, which in return gives you the value of 00, 02, 46 and 94. And when you type this in, just basic hex to decimal conversion, you will get a value of 149,140 millimeters remaining length, which equals 149 meters. Now the new state of the EEPROM chip has a remaining filament amount on the same byte position, line 30, which is the hex code 80 A9 0300. And the same principle, we're going to do a little endian conversion, swap around the bytes, and this will get us, if we're going to do a quick check, 03 A9 80, we're getting 240,000 millimeters, thus 240 meters, which is the maximum length we set in the Arduino code. So this is basically how it works. Another important feature that the Arduino code is doing, because of the newer firmware versions of the XYZ printers, they record the least amount of remaining filament that was used in conjunction with a certain cartridge serial number, and it records this in XYZware, and probably it's uploading this to the web. So we're going to have to go ahead and increase the serial number by 1 from 67 to 68. Thus we're able to always reset our EEPROM chips in the filament cartridge. So going over the log from the Arduino, we can see that it read the EEPROM, then it's updating the EEPROM with all success messages, meaning it applied all the modifications for filament length and updating the serial number, and then it's dumping the new EEPROM again just as a verification. The most important check you're going to have to do is check if the serial number was increased by 1, and that should be an indication that it worked properly. Now we're going to go ahead and install the third-party filament. And by that we're going to open up the lid and reinstall the newly flashed filament cartridge, and make sure you have the EEPROM towards the middle. Then we're going to have to close the box again. Now in this case I'm using a 1.75mm ABS filament from Voltivo. This is the natural beige, and we're going to have to insert this through the slot in the back between the lid and the casing of the printer. You have to be careful because the slot's kind of not big enough for it to work properly. You're going to have to do this a little step by step by closing the lid again a few times. You're just going to push it through the same guidance hole for the filament. And we're going to pull out a sufficient amount into the printer. With a pair of scissors, we're going to cut the tip at an angle so it's easier to insert the filament, just as recommended by XYZprinting's manual. And now all we have to do is insert the filament in the extruder and be sure to pull over the lever while you feed the filament, and you will feel when it's fully pushed in. Then that's it, we're going to close the lid, and next we're going to install the holders for the filament roll. On the inside we're going to have a quick look at where we can mount the filament holders. You have to watch for this corner as it's only possible to go so far to the right. And we're going to insert it. And now on the other side for the left. I'm just using a basic pencil, it was the easiest I had for support. And we're just gonna go ahead and fix the roll with the two holders and the pencil. The only downside with my filament roll holders is that you cannot open the lid anymore. You have to be aware that you can't slime it open, so you'd probably end up breaking it if you try doing it. You can still access the inner side, you just have to stick in your hand from the front and you can still do some work if you have to. Make sure the filament's properly installed. Let's go into utilities and load the new filament. So as soon as the extruder is done heating up, it will automatically feed the new filament through the nozzle. And it's going to ask you if it was successful or not. You can see if there's filament coming out of the nozzle. And the EEPROM modifications we're doing this way also work on the latest firmware and the latest XYZware software, as I've been using the latest versions from the website for my projects. So I'm going to show you that the filament EEPROM resetting worked. We're going to go into the statistics. And here we see the remaining capacity is now 240 meters instead of the 149 meters it was before. It's still the same black ABS material. A big thank you out to you guys for taking the time and watching my video. If you like what you see, please hit the like button and subscribe to my channel. In the upcoming video I will be talking about using a third-party slicer for the XYZprinting da Vinci 1.0a printer.